Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 42 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a customer here purchasing an electronic device, right? So let me open up my graph draw feature here. We are going to need this. Purchasing something for $650, and then it's going to decrease by 30% each year. All right, so it's not necessarily giving us which type of function, linear function, quadratic, exponential, but we should hopefully see a few different things within this to let us know that we're dealing with an exponential function. So let me call out what I saw that gave me the clues here that we're dealing with exponential function. This is our standard form of exponential function. So really we're just looking at the A and the B. All right, so your A is going to be your initial amount. And so it could be your starting price, like it is in this particular problem, might be the starting population, and then we're looking at population growth or population decay. Could be investment, compound interest, and it's the principal that's being invested. Anytime you have something that says starts with something or an initial starting number, okay, this should make you think this might be an exponential problem, okay, because it needs a firm starting number, 650. Now this is either your growth rate or your decay rate, depending on whether it's increasing or decreasing. And that was my second clue here. Each year, the electronic device decreases by 30%. So we get the word decreases and 30%. So this is our B, because it's a decay rate. And thirdly, this X right here is always going to be in these types of situations some type of unit that you're multiplying by. Typically, it's going to be a time unit, days, weeks, months, years, just to show how that 30% gets compounded there. And it says each year, okay? And the X right there is the number of years. All right, so those are my clues that we're dealing with something that's exponential, right? So let's write this. Okay, so Y equals, my A term is 650. Now, here's the thing with my B term. Decreases by 30%. It's a growth rate if it's over 1. It's a decay rate if it's less than 1. Now, we have to do a little bit of work here. Since it's decreasing, we know it's a decay rate. If you multiply it by 1, anything by 1 stays the same, right? So it's going to be 30% less than 1. So we need to translate first that 30% into 0.3. And it needs to be less than 1. 1 is just everything staying the same. So you actually have to supply that or subtract that in order to get this 0.7. Since it's less than 1, it's 30% or 3/10 less than 1. It's the same as 7/10. All right, so there we go. That's our equation. If we wanted, we could graph that. So let's look at some of our statements. The y-intercept of the graph is 650. Well, what happens when the y-intercept is when x equals 0. So what happens right here if x is equal to 0? Well, if x is equal to 0, it's 0.7 times 0. Anything to the 0 power is just 1. So 650 times 1. So it looks like it'd be 650. So that's looking pretty good. 650 makes more sense than 455. The graph has a vertical asymptote of x equals 0, horizontal asymptote of... Okay, so we are going to have to graph that to verify. So let's just go ahead and open up our graphing calculator here. All right, we're going to say y equals... And then what was our problem? We said 650, 0.7. All right, so 650, and then 0.7 x. So it looks like our horizontal asymptote is going to be that y equals 0, and we probably crossed right up there around that 650 mark. So our answer here is A.